2017 B2. So the image on the right shows a playground incorporating two planar surfaces that intersect. Okay, there's also two circular portholes. The horizontal and vertical coordinates of the two intersecting planes, A, B, C, D and A, B, E, F are also given. Okay, so we can start off with 0 on the page and find all of the coordinates. So I'm going to give you a couple of minutes to do that. And then we're going to draw the plan and elevation of the two intersecting surfaces A, B, C, D and A, B, E, F. Off we go. So starting off in the middle of your page, okay, label a point to be 0 and then from that you're going to find all your other points. So I need to measure out 205 for A, 235 for B, 195 for C, 185 for D, 145 for E and 135 for F. When you have all of those, as you've seen time and time again, you're going to do vertical lines at each of these. Okay, and we're going to find the heights of each of these. So A is on the ground. D is on the ground and F is on the ground. The other two measurements I need are 20 and 60. Transfer them across the page. Okay, so B is 60 and E and C are 20. We can now start joining this together. Okay, so A, B, C and D. And E, F. A and B. Okay, now that we have that plane done, we're going to do the same in plan. We'll find all of the points that we require. So I need 10 all the way down to 110. So I need a distance of 10, 40, 10, D was 110, C is 100, B is 60, sorry it's not, F is 60. E is 50, A is 40, and B is 10. Label all of these as you have seen from the question. So I have A, B, C and D, E and F. And do the same in plan. So A joins to B. Sorry, now G, C and G, and that's F and E. So A and B, B joins to C, A joins to D, and D joins back to C. Okay, so we have 2 planes done as requested in the question. Okay. Now that you've that done, we are now going to get the dihedral angle between the surfaces A, B, C, just between the 2 planes. So our line of intersection we've been given. I'm just going to show you our steps. So we need to find the line of intersection and get the true length of the line, then look along this line, bringing out 2 points, and then measure the angle. Okay, so there are 4 steps. So AB is obviously the line of intersection in between the 2 surfaces. It doesn't matter if you go up or down the page. I'm actually going to go up the page this time. Okay, so our XY line has to be parallel to A and B. I'm just moving out away from the object. Label your X1, Y1, and bring out all of the points that you require. So A and B anyways. Now, 2 other points, 1 from each surface. The easiest points to take are ones that you don't need to measure, so ground points. So on the surface A, B, C, D, D is on the ground, and on the surface A, B, E, F, F is on the ground. So if I bring out D and F into this view, they happen to be on the same line. They're on the ground. We're now going to transfer the heights from the question. So as I just highlighted, D and F are on the ground. And what I need to find now is A is also on the ground. And B is up high. Take the height of B and transfer it. Join A to B together.
Could all 6th teachers please set down an absence?
Okay, once you've joined B and A together, you're going to look along that and bring out D and F also. We're going to draw a new XY line. This is our X2, Y2. And we have to work from our last XY line back. So these distances are quite large. It might go off your page. It is okay if that happens. So taking the distance from A to B first. That is the same distance A and B. So from our XY line, strike it off. So I found A and B. We're then going to get the distance to F. And we're going to strike it from our new XY line. And then we're going to get our distance to D. And strike it from our new one. Oh, it just fits on the page, brilliant. Okay, I'm not sure if you can actually see that. Okay, but I found D down directly underneath. And all I'm going to do is measure that distance. Okay. joining AB to D and AB to F. And that's my angle directly in the center. I'm going to measure it with my protractor, and don't forget to show its dihedral angle. With the dot in the center. This angle is 70 degrees. Okay, now that we have the dihedral angle found, and that was part B of the question, so I'm just going to highlight this to you. So I've drawn the plan elevation of the two intersecting solids. I've determined the dihedral angle between the planes. I now need to determine the true shape of the surface ABCD, so this surface to the right hand side. And I need to get the true shape and include a 20mm circle for the porthole, given that the centre is 30mm away from the line AB and 50mm away from the point D. I'll come back to that again in a little while. I'm just going to move this out of the way now for a second. So the angle of 70 degrees we've already found. Now, I need to get the true shape of this surface. And when you need to get the true shape of a four-sided figure, you need to get the true length of all four lines. At the moment, I only have the true length, really, of AB. And I'm going to talk about the other true lengths now shortly. I'm going to use a range of colours for this. Okay, so with a four-sided figure, we are going to split it up into two triangles. And I'll explain why in just a moment. It doesn't matter if I join B to D to create a triangle or A to C to create the triangle, it's all the one. I'm going to join A to C. In maths, you have learned how to draw triangular shapes when you have the three edges and you use your compass to do so. I'm going to use that principle and I'm going to get the true length of all of the sides. I'm going to tick off as I have them. So I have the true length of AB, I found it here. So that's the true length, that's one measurement I've got. Okay, AD is on the ground and I'm looking directly down at it. So this is a true length number 2. I do not have the true length of BC, I'm going to have to find it. I do not have the true length of CD, I'm going to have to find it. And I do not have the true length of this diagonal, I'm going to have to find it. So I have 2 out of 5. I have to take 3 more auxiliaries in order to get all of the true lengths. It doesn't matter where on your page you do this, as long as you spend the time in actually getting all of the true lengths. So I have AB already, I have AD already. I'm going to get DC. And I'm going to get this by coming out perpendicular to it. I am going to be drawing on my plan a little bit for this, so don't worry about it. So new XY line. Take out D and C. D is on the ground, so it's already brought out. So D is here. And I'm going to take the height of C next, and that will be its true length. That will be a third one. And just to keep consistency, what were we on? X2, Y2. This is an X3, Y3. And when I join D and C together, that's a third true length. Okay, the fourth one is BC, and again I'm going to do a fourth auxiliary. Okay, so I'm going to come out perpendicular. C is up high and as is B. So again, you can draw an XY line. You can bring out B and C. C is up a little bit and B is up about 60 or that. And take their heights. C from my XY line and B from my XY line. Okay, so I'm going to label that C and B, and this is my X4, Y4. And I'm going to join B to C. That's a fourth true length. And finally, the last true length is that orange line that I need to find. Again, I need to take a fifth auxiliary. So it doesn't matter where I take it from, but I'm going to draw another XY line out here. It's okay that they're overlapping. This is an X5, Y5. I'm going to come perpendicular and bring out A and C. A is on the ground, isn't it? It is. So my, she can't see my X5, Y5. A is there. Oh no, it's not. Give me 1 second. I can parallel, I just can't see where my parallel line, oh it is there. So there's A. And finally I'm bringing out C. Take the height of C from your elevation and bring C out. And join A to C, and that is my 5th height, width, true length. Okay, that's number 5. Okay. Now that I have all 5 true lengths, 1, 2, 3, 4, and 5, that's this shape here. I'm going to do it out to one side, just out of the way. When you do any true shape, just pick a point to start. It doesn't matter where on your page. I'm going to use my XY line as the ground, so we have that already. Now I can start on AD or whatever. So I am going to start on the line AD. So there's A and D. I need to find where that true length of AD is, and that is on the ground. So take the distance from A to D, strike it off. So now I have AD. For the triangle I'm talking about now, it's this triangle inside here. I need to do D to C. D to C is my 3rd true length. So I'm just going to take that true length on my compass, and from D I'm going to strike it off, because it's C I'm trying to find. Okay. And the last bit of that triangle is A to C, which is my number 5. Take that distance on my compass and strike it off. That was the orange line I was talking about earlier on. I created a triangle in the middle of a 4-sided figure. So I'm just going to draw that in orange, just so you can see the relevance of it in a couple of minutes' time. And I'm just going to join that back in. So that's point C, is what I found. Okay, because we know how to draw triangles using true lengths, but we don't know how to draw 4-sided figures or 5-sided figures. You create triangles on the surface. Okay, so at the minute I have AC. From C I can do C to B and A to B, and I'll get the next triangle in. So I'm going to do C to B next, which is this distance here. Take the distance on my compass, C to B, and from C strike it off. And then take A to B on my compass, which is this first true length that we found at the very start, and from A strike it off. Now that we have that point up there, which I'm calling B, we can draw in the true shape of the entire surface. Join A to B and join C to B. Okay, so we didn't know what the angles were, but now that I have the entire shape done, I have the true shape of this surface inside here. What we were asked to do is we have to draw a circle on that surface, and the circle has to be a diameter of 20. It needs to be 30 millimeters from the line AB and 50 from the point D. So AB is here, and I need to measure 30 millimeters away from it. So grab your set square, measure 30 on your set square on one of the lines just away from it. And because it has to be 30 millimeters away from the line AB, you need to slide your set squares and get a line parallel to it. Okay, so my center line has to be on that line somewhere. It also needs to be 50 millimeters away from D. So measure 50 on your compass, and from D strike it off. Now that is 30 away from AB and 50 away from D. I've got a center point. Okay, with that in mind now I can measure 10 on my compass and draw the circle in. Okay, so it's a diameter of 20, that means it's a radius of 10. So it doesn't matter, just measure 10 on your compass. Now it is going to be tricky to measure 10 on your compass and draw the circle accurately, but do it as best as you can. Okay, there we go. There is one of the portholes done, and that's part C of the question done. We got the true shape by getting all of the true lengths of all of the lines. We created a triangle on the surface, and we then drew the porthole in the center. Okay, so I've done parts A of the question, which is drawn plan elevation, B, which was getting the dihedral angle, C, which was getting the true shape, and part D of the question is find the midpoints of the lines AB, AD and AF, and then that define an oblique plane, and then get the vertical and horizontal traces for it. Okay, so just quickly, we're going to bisect the lines. We're getting the midpoint of AB, AD and AF. Now you can do this in plan or in elevation, doesn't matter. I'll do it in plan. So remember, to bisect a line, you go more than halfway, draw an arc on each side. Draw the line in and we'll get the bisecting point. Repeat this process on AD and AF. Okay, now that we have that done, I can actually draw in that plane lightly. And with that in mind, I can draw in the plan a little bit heavier than I had it in because I purposely left it light until this stage. So I'm going to put in the plan in heavy now. Now, okay, find this plane up in elevation now next by just finding the points directly up by using your T-square. I know there's a lot of lines going on, but I've got the midpoint of line AB, so bring it directly up. So I've got the point on AB. Find the midpoint on AD. And find the midpoint on AF. And join all three together. Now you're asked to measure 5 millimeters up in elevation. So measure the 5 mil, and that's where the plane will be heavy. So now that plane can go in heavy now. The hidden detail also put in. Now, okay, these 2 points now need to be brought down into plan because that's where the plan finishes off in heavy. And I'm just going to colour in the plane that I'm talking about. Okay, so this is the oblique plane that we've been asked to find. I have 2 points on the ground, which were the midpoints of AF and AD. And I've measured up the 5 mil like I was asked to find the exact bit that we're looking for. We are now asked to determine and indicate the vertical and horizontal traces for this plane. Well, this is actually nice and easy because we have 2 points on the ground. I'm going to do this in blue so you can see it really clearly. So the midpoints that we found at the start of the question are here and here. There are 2 points on the ground, so they have to be the horizontal trace. So draw the line through it and call it HT. To find the vertical trace, you come parallel to this line through any of the points on the surface. Okay, so we are just going to come parallel to one of the points on the plane. So we have 1, 2, and 3. Because this is the highest up one, we can use it. So come parallel to 1, see where it touches on the ground. And then you're going to bring that point up and across to meet it. So bring it up and bring that point 1 across to meet it. That has to be a point in your vertical trace. So when you join it, that's the question fully complete. So that's your V, T, and H. This question was a tricky question. There was a lot of parts to it and a lot of work that was needed to actually complete it. Nearly the easiest thing from all of this was the dihedral angle part of the question. Getting the true shape was tricky. There was a lot of parts to it. And getting the VTH at the end was fine once you had found the original plane. Okay, so just make sure you label this. This is the 2017 B2.